Volumes of solid. We know how to find the volume of a rectangular box, a cylinder, and a prism. The volume of a prism is the area of the base times the height, as long as the height is perpendicular to the base. Suppose now we have a solid that is not any of the well-known geometric shape. This solid lies between x equals a and x equals b, and we're looking for the volume of this solid. Since we don't have the formula to find the volume of this solid, we will slice it perpendicular to the x-axis so that the thickness is delta x and the area of the cross-section is a of x. There will be n of these slices. Each of the slices has a width of delta x, where delta x is b minus a over n. The volume of a representative slice is therefore v of I is a of xi times delta x. The total volume from x equal a to x equal b is v equals v1 plus v2 plus all the way to vn. This is the sum as I go from 1 to n of v sub I. But each of v sub I is a of xi times delta x. We recognize that this is the Riemann sum, which gives us the definite integral from a to b of a of x dx as long as n goes to infinity. Now this only works if a's of xi share the same formula for I equals 1 all the way to n. In this particular case, the cross-section is a rectangle. The area of the rectangle is the length times the height, and therefore the volume of the cross-section is the length times the height times the width, but the width is delta x in this case. We would need to express L and H in terms of x because of the variable of integration is x. Let S be the solid that lies between x equal a and x equal b. If the cross-sectional area of S in the plane P sub x through x and perpendicular to the x-axis is a of x, then the volume is a definite integral from a to b of a of x dx. To find the volume, we sketch the solid, find the volume a of x, find the limits of integration, and we integrate it. In some cases, we might need to slice the solids perpendicular to the y-axis so that the thickness is delta y instead.